In problem number 5, you're asked to find the volume of the solid obtained by rotating the region bounded by the given curves y equals 2 over x around the and y is equal to 0 around the given line y is equal to -1. So the first thing that we need to look at is a picture. Here we've got a graph of y is equal to 2 over x, and then here we've got y is equal to 0. It's important to note that in these problems, when you're rotating around a line that's not an axis, it's potentially possible for our axis to actually be the bottom function. In this case, we have that. Y is equal to 2x and y is equal to 0 are our two functions, and in green you can see the region that's bounded by these two functions from x is equal to 1 to x is equal to 4. The object is we're going to rotate around y is equal to 1. In doing so, we create some sort of shape that looks like a lampshade. The outer function is y is equal to 2x because it's the function that's farthest away from the line that we're rotating around. The inner radius is what we'll call the function y is equal to 0 because it's the function that is closest to the line. When we rotate, we're going to create this lampshade kind of shape. So we need to make sure that we actually find the volume when we rotate 2 over x around y is equal to -1, and the volume that we get when we rotate y is equal to 0 around y is equal to -1 will be subtracted away from the volume of the original solid that we get when we rotate y equals 2 over x around y is equal to -1. In doing so, we get a washer shape. How is the formula set up? As with the previous formulas, we've got our outer radius, which comes first. We're going to square that function, integrate and multiply by pi, just like with previous volume problems, and then we've got our inner radius of y is equal to 0. The adjustment that we'll have to make is that we're shifting everything down by 1 unit by rotating around the line y is equal to -1. And so in doing so, we need to subtract outer radius minus line, then square, inner radius minus line, and then square. And as discussed in class on Wednesday, we can plug both of these functions into our y equals. If need be, we can find our points of intersection and store those as a and b. When we use our calculator, we find out that the volume formed is 26.845.